Okay, so good morning. So good afternoon. Okay, good afternoon. So we are now in the second session of today's class. So we already almost finished the factor analysis. Yeah, just now. Okay, but any question you want to ask? Yeah. So as usual, we am I attendance for the next section. Okay, so this section no. Of course, the duration is still 5 hours. Yeah, for today. Okay. Okay. No. Okay. Okay. So wait. Um, of course can. No. Uh, okay. Good question. Um, okay. I show you now. Yeah. Okay. The SPSS can do table like this. Yeah, but not like this. Means they just follow the sequence, but not based on the value of the correlation coefficient. Okay. So here actually we do it manually. Yeah, I mean this table. Yeah. Okay. 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 So if no question, now we see next. Yeah. Okay. So now we done already the rules of thumb 3-7. Now we see 3-8. Okay, correct. So now we are here. Okay, we see the advantage and disadvantage here of the three methods. Okay, so if you the first one, the single variable. Okay, the advantage is simple to administer and interpret. Yeah. Okay. No, actually it's not easy to interpret. Not easy. Yeah, easy to handle, but not easy to interpret. Sorry. Uh, correct. Because only one variable, correct. Therefore, easy to interpret. Yeah. Okay. Therefore, it is correct. Okay. Uh, therefore, easy to handle, also easy to interpret. Okay. But this advantage is that does not represent all the faces here of a factor. So a factor, let's say got three factors, but we take only one, yeah, the highest loading. Yeah, therefore maybe they cannot represent all the factors. Yeah, and because of this, therefore they are prone to the measurement error. Okay, the single factor. So now we see if no question, we see second. Second is the factor score. Okay, the advantage is that as compared to the previous one, is the factor score is better because they can represent all the variables, all the variable loadings on the factor. Because let's say the factor got three variables, we take all. Okay, so we consider all the variables here in the calculation of the factor score. Okay. Okay. It's the best method to complete the data reduction because it represents all the variables. Okay. So these are the by default these are independent and can avoid complications caused by the multi-collinearity. This is the methodology. So therefore, not much problem by the multi-collinearity. Yeah. So even there's a correlation. Yeah. This correlation among dead factors, but they can handle this. Okay. By default, it means by theorem. Okay. So therefore, it's good in terms of the statistical property. Okay. Okay. But the problem is that difficult to interpret, like what I think a friend mentioned just now. It's difficult to interpret because you combine all the variables, and all the variables contribute through the loading on the vector. Okay, and then also difficult to replicate across study. Okay, so because in your study you use x1, x2, and x5 to represent a vector, but other study because their data different, yeah, maybe finally they come up with different vector. They got x1, x3, x6, therefore different. It's not cannot it's difficult to replicate across studies. Okay. Okay. So if no question, now we see next. Yeah. So, submitted. Okay. Therefore, it's in between. Yeah, compromise between the single variable and also the vector score option. Therefore, it's in between. Okay. So can reduce the measurement error as compared to the single vector. Okay. It represents the multiple phases of a concept. Because here we still consider a few variables to present one vector compared to the this method. Okay. Okay. So easily replicated across studies compared to the vector score. Okay. So vector score must see the outcome, but for you no need. Okay. I mean for this one no need. Okay. So disadvantage include only the variable that load highly on the vector, then exclude those having little or marginal impact. This is disadvantage. Yeah. So okay, but remember the policy is in between the single vector, the single variable, and also the vector score. The vector score take everything, but here take only one or two, maybe two like that. Okay. Okay. They're not necessarily independent. Okay, so independent is good because between the factors, it's supposed independent. Okay. Okay. So required extensive analysis of reliability and validity issues that we discussed just now. Okay, got few this one validity and also reliability. Yeah. Okay. Okay, so this what this one done already for chapter. No, one more. Yeah. So the data that we actually also seen it already, but maybe our data not complete. Yeah, but it's okay. It's still good enough for us to do the data, the vector analysis.
Sorry, sir. Can I ask you about the surrogate variable? Surrogate variable means we inside the factor we have a few variables. We pick one to represent for the factor.
Correct.
Thank you, sir.
Correct. Yeah, good. Yeah. Okay. So if no problem, now we see this one. Okay. This is rotated. Can you see it's rotated? Yeah. So therefore, like this is very good because example here these three they represent the first vector. These three they represent the second vector. Okay. So here actually got some value, but they did not report here. Okay. So remember here, this one power 2, power 2. Each value here, power 2, power 2 is sum together. We get this. Okay. Okay. So this is rotation method. Okay. Okay. This Grace plot. Therefore, we take only the first four. For this one, we take only the first four because this is above 1. This is cut-off point. Yeah, 1 is cut-off point. Above 1, good. Below 1, not good. Okay. So, okay. So can you see here? In SPSS we call it component, but actually same thing. Same thing. Component is also vector. Same thing. Okay. Okay. Any question? Yes. I mean, we should follow by multiple discriminant. Then not follow this. Okay. Means once we finish tutorial, we should discuss the multiple discriminant. Okay. Then logistic. Okay. Then after that, because we follow the sequence, I think some technical issue. We should follow the sequence here. Okay. 1, 2, 3, 4, 5. Yeah, we follow this one. Okay. Okay. So if no problem, now we see this one. Okay. Each question you want to discuss? Yeah. 1 until 7. Yeah, you can text in the chat box. Yeah. Let's see, any question? 1 until 7, okay. Okay. Okay, we see one by one. Yeah. Okay. What are the major issue of the factor analysis? Means it's more to the data deduction. Okay. So major use. Okay, major use is correct. So it's more to the data deduction. We want to, let's say there are many factors here in the data set 50. Yeah, you make it more structured, you get only few variables. Okay, and then you may use the data. Okay, therefore you got better understanding on the overall problem. Okay, the issue. Yeah. Okay, so and then second thing, you may also use the data, the outcome, here for you to do some data analysis here in other method, let's say in multiple linear regression. Okay. So component analysis here actually refer to the principal component analysis. Okay. So basically, principal component analysis, we actually want to, okay, so we want to identify the important component. Yeah, each one not too important, each one least important. Okay, but the common factor analysis, we want to find the common variance. Let's say the first factor, they have the similar idea. Yeah, common variance. Yeah, is similar concept. Therefore, group together. This one I see is quite similar between these two ideas. Okay, so but okay. Okay. So each rotation of factors necessary, yes or no? Answer is no. Yeah. Because let's say the first matrix, yeah, the first matrix they give you 4 factors, and you can easily see which variable belongs to each vector. Therefore, it's okay. You can proceed without using the rotation. Okay. Therefore, not necessary. Okay. So as long as the outcome you can see each variable they belong to one factor. Okay, you can easily do the grouping. Therefore, it's okay. Yeah. How do you decide how many factors to extract? Of course, we can use the eigenvalue more than or more than one. Okay, more than one. Yeah, more than one means consider means the factor is important. Okay, the factor is important. Okay. Okay, actually, Chris brought also same idea. This is a diagram. Okay. Okay. So this the eigenvalue. Yeah. Okay. Of course, you can also use the past study. Yeah. Okay. So let's say your questionnaire, you design the questionnaire is for 6 factors. Yeah. Therefore, you should actually try to find 6 factors. Yeah. From your data. Okay. What is a significant factor loading? What is a significant factor loading? It means the value, is it? I think maybe not too clear. What is a significant factor loading? Okay, should be referred to the value. Okay, so factor loading is factor loading is loading is the relationship between the variable and also the factor. Okay, therefore minimum 0.5. Okay, can be also 0.6. Okay, but let's say you want to use it, you must have some reference. Okay, you do some citation. Okay, any question so far? Maybe too fast. Okay, any question? Yes. Number 5 until 1 until 5. Okay, so we see 6. How and why? Yeah, how got 3 method. Yeah, how got 3 method. First method you consider all the variables that belongs to the factor and find some common thing. Yeah, so example can be commitment, or maybe transport or other terms. Yeah, more general term. One or two works, but they can represent all the 3 or 4 variables. Okay, that's how. Okay, so second method, in case cannot find the term, therefore you can consider, in case you can find a term from all the variables, you can find part of the variables. let's say altogether 5 variables belongs to factor 1. 5 variables belongs to factor 1. You may consider 3 or 2 variables. Encumber a name. Yeah, the name can be used to represent the 2 or 3 variables. Okay. So the last method is that you only use the variable with the highest loading. Okay. So to represent that factor. Okay. Why? Yeah. Why do you name a factor? I don't know why you must ask why. Okay. So because of course easier for the interpretation and also understanding of the problem. Yeah. Okay. If you put all the variables together, it's not easy for people to imagine the problem. Okay. Okay. Of course, we can list down. Yeah, we can list down 1, 2, 3, 4, 5. But it's we want you want people to understand the concept, the idea of the problem faster, easier. Therefore, you give a name, yeah, of the factor. Okay. Of course, the factor is try to find a factor as best as possible to represent the whole all the variables that belongs to the factor. Okay. Okay. Should you use the factor score or segmented rating to follow up analysis? Yeah. So of course here you can refer to the advantage and also disadvantage, yeah, of the factor score and also segmented score. Okay. So this one no uh, no single answer. Okay, to answer this. Yeah. Okay. 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 So, but we can give some context, yeah, some situation, so to see which one is the yeah, wait, filter score and what? Okay, filter score and submitted. Okay. Okay. So filter score and submitted. Okay. Example, let's say you you suspect maybe this problem of multicollinearity. Therefore, you better use filter score. Okay, because can avoid the problem of multicollinearity. Okay. So, but if you worry, yeah, using the factor score may not easy to do the interpretation. Therefore, better use the submitted skill like that. Okay, so depends on the means you can discuss in that way. Okay, depends on case, depends on situation. Okay, okay. So another example, let's say you worry, yeah, that the sampling error may be high. Sampling error, measurement error may be high. Therefore, you can use the submitted skill. Okay, can reduce the measurement error. Okay. 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 So any question on this? Means you focus on the advantage and disadvantage here of the submitted skill and also the factor score. Okay. So that's for chapter okay. Factor analysis. Okay. So we done already for the factor analysis. Yeah. Any question? Yes. Okay. I'm sorry. Before that, we should discuss tutorial. I forgot about tutorial. Okay. Tutorial factor analysis. Okay. 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 Why? What are the differences between the objective, yeah, of data summarization and also data reduction? Yeah. Anyone want to try? So you summarize it, and then make it from 20, and make it become 4 variables, 4 factors like that. Okay. Reduction, some you can just remove like that. Okay. Let's say the one if least important you can remove. Okay. It's more to data reduction. Okay. Okay, of course, you can elaborate more. but it just tell you some important points. Okay, so we see how can factor analysis help the researcher improve the result of other multivariate techniques. Yeah. Okay. So okay. Okay. This one also discussed a bit just now. So okay. You can give example. The other multivariate needs to refer to the multiple linear regression. Okay. Okay. So okay. Let's say your data have 30. I think this okay. Good enough. It's the same thing discussed already. Okay. You have 30 independent variables. Yeah. If you include everything, will be too much. Okay. Because this will consume a lot of the degree of freedom. Especially if you have many, if your n is quite small, your sample size too small. If you use 30 independent variables, this will consume your degree of freedom. Therefore, the result may be not too good. Okay, so therefore, from 30 variables, you can use factor analysis. You have to make it become maybe 4 or 5 factors only. Yeah, therefore, you have 5 independent variables compared to 30. 5 is better. Yeah, you consume lesser degree of freedom, yeah, in the multiple linear regression. Okay. Okay. Okay, wait. Okay, wait. Okay, for assignment, no need. Okay, for assignment, no need. But case storm, yes. Yeah, assignment, no need. Okay, no need. Yeah, it means no need to do citation. Okay, yeah, answer your chi xiong. Okay, okay, okay. You can get this. You can get this, but they did not do the grouping. Okay, now they did not do. You can get the okay.
Yeah, I can't find the grouping. Sorry.
Okay, you cannot do the grouping. You can get the this one, but not this one. Okay, they just show everything, but not the grouping. Yeah, they did not group the high correlation together. Okay. Yeah.
Yeah.
Okay. So we see next. Yeah. Okay. So continue. Yeah. So now we are here. Okay. What guideline can you use here to determine the number of factors to extract? Okay. So basically two, right? Because Chris plot eigenvalue same. Yeah. So therefore two, one is the based on the past study, second is based on the eigenvalue. Okay. So you can explain one by one. Yeah. Okay. Okay. So how do you use the factor loading matrix here to interpret the meaning of factors? Yeah. Okay. Oh.
Excuse me, sir.
Again?
For question 3, you say guidelines, right? The first one is to use past study. The second thing you mentioned, what was it again? What value?
Eigenvalue.
Value. Okay, thank you.
Okay. Okay. So how do you use the factor loading matrix here to interpret the meaning of the factor? Of course, you find the loading. Loading is the correlation between the variable and also the factor. Okay. So from there, you find the high. Yeah, you find the high loading. Yeah, and then from there you know which variable belongs to which factor. Okay. And then from the, let's say got 5 variables, it belongs to factor 1. Therefore, these 5 variables, you can use these 5 variables to give a name, yeah, to interpret the meaning of the factor. So find the similarity among the 5 variables. Okay, that's the process. Okay. So therefore, yeah, we can use the factor loading matrix to interpret the meaning, yeah, of the factors. Okay. Okay. Any questions for number 3 and number 4? Okay. Okay. how and when should you use the factor score in conjunction with other multivariate statistical techniques? Okay, so here of course you focus on the advantage here, advantage of the factor score. Okay, you can see a little bit. So I think the first one is it's okay. We see. I think already mentioned is it. They say you suspect that there's problem of multicoordinality. Yeah, example the VIF is quite high. They say 8 or 9, so it must be careful. Already a signal for you. Yeah, okay. Maybe there's a problem. Yeah, of course we still stick on 10. Yeah, 9, 8 still okay, but it's quite close. Maybe it's a signal. Okay, that is a problem, but not too bad like that. Okay. So must be very careful also when it's quite close to 10. Okay, like that. So okay, when they should use when is it a question? When you should use the factor score? Okay. So this is the first method. Yeah, if VIF is quite high, yeah, for certain independent variables. Okay. So okay. Another one is that another one you see this one difficult to replicate across studies. Actually depends on the purpose of your study. Let's say you study only for your, it's a project for your what they call for other company. Therefore not important. You have to replicate the across studies. Not important. So only for the project. But let's say the purpose is to publish the paper in journal. Therefore it's important to have this replication. Okay. Okay, so depends on the purpose of the study. Yeah. Okay. So we can discuss some advantage and also disadvantage. Yeah. Okay. So okay. So example from the disadvantage, if you have no problem in the interpretation of the what do you call the factor, means you already have the 4 factors that they can be used to represent the variables. Yeah, therefore you can use the factor score. You can see, yeah. Okay, means remember 5 variables. You find the factor. Yeah, if the name is very good already, yeah, therefore you can use the factor score. Means no problem for you. You have to do the interpretation later. Okay. Okay, so this is the to answer number okay, how and when. Okay, means also can discuss a bit how. Yeah, how to use factor score. Maybe easy because the software can generate for you. Yeah, so make sure you save the factor score. Yeah, when you do the analysis. Okay, therefore you may just copy the can just use the factor score as independent variable. Okay, yeah. So number 6, the different. Okay, also discussed already. Yeah. Okay, so the different factor score, they consider all the variables and they come up with one score. Submitted also one. Submitted also one, but they use the original data to do calculation. Okay, which one is more better? Of course, depends on the case lah. You still come back to the advantage and so disadvantage of these 2 methods. Yeah, factor score and submitted skill. Okay, so we done already for chapter for factor analysis. Okay, any question? Yes. Okay, so if now we see the new chapter, okay, multiple discriminant. Okay, so this one will be tested in your quiz 1. Okay, we see this now. Okay, so this is the example. This example of the supervisor. Okay, the supervised machine learning. Yeah, I'm not sure when we should use the software, but anyhow, you may stand by. First, okay. You may stand by first. You're the software. Okay. Okay. We still use the same data set. Yeah. So, this is MDA. Multiple discriminant analysis. Okay. So this one is means that why we call it supervised. I think you know, right? Anyone learn already machine learning? Is machine learning a module? No. Oh. But you're supposed to learn machine learning, correct? In any in a module? No. Okay, it's okay. You may learn this later or before. Okay. But meaning that we know already the outcome. Yeah. Okay. Example. Yeah. Okay. Okay. So let's say example, a group of people, they go for interview. Yeah. And then let's say you are helping the your assistant, of the HR manager. Okay. You got the data. Yeah. Okay. So you got data, therefore you know which candidate fall into the KIV, which one are under accepted category. Okay. So these two we know already, and these two are the dependent variable. Okay. Here got two categories. Can be 3, can be 4, but here let's say two. Okay. It's okay lah. HR normally HR know the result, but they did not tell you. Okay lah, normally. Let's say even you are rejected, but they will tell you KIV. Normally like this. Okay. So let's say we got 3 categories. Okay. And then the dependent actually must be nominal. Okay. Must be categorical variable. Okay. And then the independent or metric. Independent or metric. Example. Okay, example, working experience. Okay, working experience. Okay, how many years? Therefore, it's metric. Okay, so example, okay, schooling years. Remember education level. We can have, okay. I think I discussed this before. Okay, education level depends on you. You can make it become quantity. You can make it become metric or non-metric. If you want, means you just change your question. Therefore, you know. Therefore, you can get the data that you want. Can be metric, can be non-metric. Okay. If you want your metric, you ask schooling years. Okay. You ask how many schooling years you have. Therefore, let's say 6 years. I mean for Malaysian. Okay. So normally 6 plus 5. Yeah. So 6 years primary, 5 years in secondary, and then uni maybe 4. Yeah. Foundation plus 3. Therefore 4 years in degree. Yeah. I know engineering more. Yeah. Medicine also more. But let's say the more common one 4 years. Normally 4 years. Okay. A master and 2 years. Therefore 17. It will be a number. Okay. Can be non-metric if you ask okay, up to high school. Yeah. And then pre-U, and then degree. Yeah. Postgraduate and also professional. Okay. So now we want metric. Therefore, you should ask schooling years. Yeah. Okay. So now we come back here. Okay. So schooling year. Okay. And then also okay. And any other thing that HR will consider? Yes. Okay. Let's say. Okay. Let's say average rating. Yeah. Average rating. Let's say attended by head of department, and also HR, and also manager. Example. Okay, like that. Okay. So average rating. Therefore, all this will affect the outcome. You see. So either KIV accepted or rejected. Okay. Any question? Yes. So this is idea of the multiple discriminant analysis. Yeah, dependent category. Yeah, okay. So independent metric. Okay. Okay. So and then you see now you see the difference between this and also cluster analysis. Cluster analysis, we do know this. Now we are doing multiple discriminant analysis, so we know this. We know the outcome already. Means which candidate belongs to each group. Let's say altogether 100 candidate. Okay. Let's say it's a big company, yeah, it's a new company. They want to take 10 employee. Okay. Let's say 10. Okay. Okay. So we know already 100 candidate. 10 fall into this category. Yeah. Okay. Maybe here 40, here 50 like that. Okay. Therefore, you call it supervised machine learning. Okay. Okay. Any question? If not, we see next. Okay. Okay. Yeah. Thank you. Okay. So confirm is your module, but you know it start. Okay. So this is one of the example. Okay. One of the example for the machine learning. Yeah. Okay. So the test result. Okay. Test result. Yes, correct. Okay. So some company they got a test. Okay. So test. They know your character. Okay. Either you're fit or not fit. Yeah, to the company. Yeah. Yeah. Correct. Thank you. Yeah. Law. Yeah. Okay. So we continue. Yeah. Okay. So. Okay. Yeah. I'm sorry. I forgot. Yeah. What your friends say may be correct for a certain program, maybe not correct for a certain program, because this group actually got two group of students. I mean, MMDA taken by data science student, also AI student. Okay, okay, but it's okay. Yeah. So I think this one should be for data science. AI, I think so. I think also important. Yeah, to learn machine learning. It's okay. We come back to the here. Yeah. Okay. Okay. So you state the objective. We should be able to state the circumstances, yeah, under which a linear discriminant analysis, or we call it multiple, also can. Okay. So okay, this one actually done already. Yeah, just now. Yeah. So because for the multiple regression, for the multiple regression, the dependent must be metric. Okay, the dependent must be metric. Okay. So, but now the dependent is non-metric. Okay, where is it? It's correct. Okay, the dependent variable is non-metric. Therefore, we cannot use the multiple linear regression. Okay, I mean for this context. Okay. So you can also find some similar context. Yeah. Okay. So now continue. Yeah. Okay. Okay. So now we are here. At least we've done already the first objective. Okay. So identify the major issue relating to a type of variable user in sample size required in the application of the discriminant analysis. This one discuss later. Okay. So understand the assumption underlying discriminant analysis in assessing the appropriateness of a particular problem. Okay. Describe two computation approaches for discriminant analysis and the method for assessing the overall fit. So this overall fit is quite similar with the F-test. But of course, we use different method. Okay, but the idea is quite similar with the F-test. Okay. Okay. So here we are going to see the classification matrix. We call it a hit ratio. Okay, we can discuss a bit now. Yeah, because we are going to see the diagram. Okay. 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 Let's say we have only. Okay, it's okay, no problem. I follow the example just now. So meaning that accepted. Okay, accepted, and then accepted, and then okay, KIV, yeah, and then rejected. Okay. So accepted Okay, here is actually all predicted. Okay, this predicted is all actual. Here all actual. Here predicted, accepted. Yeah, and then KIV. Yeah, and then rejected. Okay. 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 So let's say here got altogether 100 applications, 100 application. So accepted 10 KIV is okay. Follow the example. So KIV 50. Okay, rejected 50. 40. Okay. No. Okay. Here, let's say 39. Yeah, here 36. Okay. Okay. So actual accepted only 10. 10 actual situation 10 40. Wait, yeah. This one we say, yeah, got no 50. Yeah, this one we say 50. Okay. So 50 here is 40. Okay. So actual KIV. Okay, so actual KIV. Okay. I think now we can see one by one. Yeah. Okay. This thing means is correct. We correctly predicted. Means here predicted. We predict that the candidate already accepted, but actually also accepted. Predicted based on the independent variables. Okay. Therefore, here got 10. Therefore, this 10 means accurate. And 39, we predicted that they actually KIV. Actually also KIV means correct. Okay. What is the meaning of 50? Means based on the data analysis, data say, the result say 50 KIV. But they are all accepted. Okay. But actually accepted. Therefore not correct. Okay now. Okay. So let's say here also not correct. Means predicted this 40 rejected. But actually they are all accepted. Okay. Any question? I think this may be something not correct. Better change the number. Maybe here, let's say maybe 3 and 4 like that. Yeah. Means 4% rejected, but actually they already accepted. Based on the data analysis, they are all rejected, but actually they are accepted. We can make this conclusion because we know the data, everything. Okay. Okay. So therefore, only the junior part is considered accurate. Is considered accurate. Okay. So therefore, finally, okay. Any question so far? Maybe too fast. Okay. Any question?
So our sample size is 100, but if the diagonal I add up is not equal to 100.
Yeah. Okay. Good question. Yeah. Thank you. Suppose not 100. Yeah. Because the junior part is 10 plus 39 and then plus 36 and then over 100. Answer? Hello? Anyone? 85, right? 85 over 100. Therefore, 85% is correct. Meaning that the accuracy rate is only 85%, not 100%. Okay? Not 100%. Yeah. Example maybe like this. Yeah. Yeah, like this. Okay. Altogether 100. Can you see? Altogether 100. Yeah. This one means not accurate. Not accurate. Accurate one only the diagonal. Yeah. Okay.
What is the optimum accuracy rate we are looking at?
Okay, good question. Actually, in general, again, no specific, but in general, half lah, minimum half. Yeah. So 50%. Yeah. Okay. I think this is end of the chapter, but in general, 50 lah, minimum 50. Okay. some textbook call confusion matrix, some textbook, yeah, depends. So here we call it classification matrix. Okay. Yeah. Okay. So if no problem, now we see. Okay. Okay. Yeah, correct. Okay. So therefore, you must know this. But again, don't worry. So we will do this for us. Okay. This one is hit ratio. Okay. 85% is also hit. In this module, we call this hit ratio. Okay. So it's of course can be number, no problem. 0.85. Okay. So we call this hit ratio. Okay. So okay, continue. Okay. So you must know what is the meaning of classification matrix, yeah, and then also how to develop. Of course, we can use software, okay, to develop the classification matrix. Okay. So and describe the way to evaluate and also the predictive accuracy. So this is a predictive accuracy 85%. Of course, we know accuracy higher is the better. Most of you should learn already time series, right? Time series and forecasting. Yeah. So accuracy higher is better. The error lower is better. Okay. We are here. Okay. Of course, you will see this also. Yeah. To find the discriminant function. Okay. Yeah. So tell how to identify independent variables yeah, with the discriminatory power. Yeah. Meaning that okay, example, yeah. Okay, I think most of you have good experience to tell me which one is more important. Where is it? Okay, here. Here got three variables. Yeah. Working experience, schooling years, and also the average rating. Each one more important to determine the status of the applicant. Anyone?
Average rating.
Average rating, yeah, okay, very good. Okay, so okay experience, okay, but it's okay. Okay, this confusion matrix, it's okay. Okay. Predicted yes, actually yes. Okay, predicted no, actually no. Therefore 150. 150 over 165 is correct. It's the same idea. They may use a different term, but same idea. Okay, very good. So it means the accuracy will be the predictive accuracy will be 150 over 165. Okay, I mean for this example. Okay, yeah, thank you. Okay, so okay, it's okay. Some say working experience, some say average rating. Okay, so you may see, of course, no data, but let's say it's average rating. Therefore, we know that this one will be the highest discriminatory power. So means this variable will be good for the CEO to differentiate the candidate. Example, CEO see rating, let's say maximum 10, rating 8 confirm better than 5, like that. Okay, so the CEO will based on the average rating to choose the candidate. Example. Okay, so therefore,
Can we
okay.
say the average rating correlate with working experience?
No. We assume average rating is more important than the working experience. Okay, in terms of the chance to get the employment. Okay, to get a job. Okay.
Maybe there is some correlation in between.
Maybe, but here we didn't see that one first. Okay, we see which one more important based on ranking. Okay, let's say average rating is really important. Therefore, the discriminatory power is highest. If highest, meaning that they can differentiate, they can determine the status. They have more power to determine the status of the applicant. Okay, now. Okay. So, okay, like that. Okay. So means let's say example. We see example candidate A, B, C. The average rating. Okay. So means the CEO trust on the manager health department, on their on their rating. Okay, rating important. Okay, they say candidate A score 8, here 7, here is 5. Working experience, this one let's say 10 years. This one let's say 15 years. This here let's say 12 years. But CEO may choose A. Yeah, because the average rating is quite high. Okay, something like that. Okay, and therefore you can say also yeah, it's discriminatory. Okay, discriminatory power, yeah, is higher. Therefore you can use this, means this variable has more power, yeah, to determine the candidate belongs to which category, like that. Okay, any question? Yes. Okay. Okay, don't worry. In the next few slides, we also got one example. Where any question from you? No. Okay. Okay. So we continue. Yeah. So we are, yeah. Okay. So we also can see the separate sample. This one discussed already. Yeah. We can apply here also separate sample approach for the validation. Okay. Okay. One full sample, make it 2. We separately do testing. Okay. Yeah, discussed already in other chapter, other chapter, right? Okay, so we see now. Okay, so multiple discriminant analysis is an appropriate technique when the dependent variable is categorical, okay, nominal or non-numeric. Okay, example just now, the what they call KIV accepted, rejected, yeah, can be also, and then the independent metric, okay. So this one, you see the single dependent variable can have 2 or 3 categories. No problem. Be very careful. Discriminant analysis can be 2 or 3 categories, but logistic must be only 2. Okay. This will discuss in the next chapter, maybe tomorrow. I'm not sure. Okay. So logistic must be only two categories. Okay. Example, you own a house, no house. Okay, like that. Okay. Okay. So example, this one maybe not so good, correct not? Yeah. Maybe not so good example. Okay. So you see heavy user and light user. Yeah. So okay. Example, heavy user of the credit card example. Yeah. Heavy user means they will what they call, they will generate more revenue, yeah, for the credit card company or bank, like that. Okay. So you may want to what they call, you may want to predict who, each one will be the heavy user. Okay. Okay. But of course the dependent is this, yeah, but the independent can be the must be the number, maybe the family size, maybe income, and so on and so forth. Okay. So purchaser or non-purchaser, you also want to know, correct not? Yeah. Let's say the potential purchaser, you may do actually more promotion, make a phone call, and so on and so forth. Okay. Okay. So this one for company, for bank to determine should the bank give give a loan or not, the housing loan or credit card or whatever. Okay. So all these are the examples. Okay. Okay. Any question on this part before we see the number? Yeah. Next slide, going to see the wait. Not like that. Not like that. Yeah. Okay. We only choose one, not choose one actually. All important. Yeah, all important. But just that, I mean all. Let's say here got 3 metric. Yeah. Okay. Here got 3 independent variables. All important. All must consider in determining the applicant belong to which category. But just that some variable have more power than others. Okay, yeah, like that. Okay, some variable got more power than others. Okay, yeah. Okay, you see next, yeah. Okay. Therefore, it's a different thing because in the factor analysis, all variables here are the same category. This interdependent. But here is the dependent because we have one dependent and the rest all independent. Okay, difference. Okay. Next. Okay, really good question. Comparison. Okay, really good question. Assuming that all the independent metric, dependent also metric, you can convert the dependent from metric to categorical. Yeah, can. We can do it. Okay. It's okay. I can answer your question now. Actually, also in one slide. Got one slide to answer your question, but it's okay. You can discuss now. Yeah. Okay. So example. Let's say a certain soft drink company want to determine who will be the non-user, yeah, non-user or maybe a light user, okay, light or heavy, okay. So they may survey, they may ask how many can of the drink you use in one week, okay, 1 week, okay. So non-user 0, yeah, light. Let's say some answer 1, some answer 2. Yeah, but you can do it this way. 1 until 5, you consider light user. 1 until 5, consider light user. Wait, yeah. Okay. Yeah. So 1 until 5, consider light user, and then 6 and above, consider heavy user. Example, maybe 1 week you drink 10 cans of the soft drink. Okay. So don't mention the name of the company. Okay, yeah, general. Okay, general. Yeah. So, okay. So means some context, not always. Some context we can do this way. Okay. So of course we can this context like the comparison mentioned, we can also use multiple linear regression. But if you converted become like this, so we can use the MMDA. Okay. Yeah. So, okay.
But sir, you can also use logistic regression, right? If you keep your dependent variables as metrics.
Okay.
If you keep your dependent variables as metrics, you can also use logistic regression, right?
No.
No.
Logistic must have only 2 categories.
Okay.
Okay. So here not too good. Yeah, not too good. Yeah.
Okay.
Okay.
Okay, understood.
Yeah, thank you. Okay. Okay. So therefore, yeah. So you give a very good idea. So sometimes from okay, this example from quantity become quality, means for metric. Okay, for metric become non-metric. It's possible. Sometimes, they're not always. Sometimes depends on the context. Okay, so sometimes from the non-metric. Okay, for the non-metric we can make it become metric. Yeah. So example BMI. Yeah, we call it quantify. You can see we quantify. Okay. So can be BMI or can be some Likert scale. Okay, we can quantify some the variable from non-metric become metric. Okay, yeah. Okay, so we continue with the numerical example. Where? Okay, so this one done. So we see the numerical example. Okay, this one done. Okay, so you see. This is a survey result for a evaluation of a new consumer product by customer. Okay, so this is the dependent variable, the purchase intention. You see the left side. Okay, we see one by one. Okay, the purchase intention. Yeah, so means they introduce the new product to some potential customer, and then group 1 say they would purchase. Of course, they give some briefing first. Okay, the briefing on the product. Then group 1, he got 5 respondents. Can you see? 5 respondents, they said that they would purchase. Okay. After the briefing, the group 2 say, I would not purchase. Okay, it's dependent or independent. Okay. For this case, not easy to change the number. Some can, some cannot. Okay. So here also 5 groups, 5 people. They may actually, you can think this way. 10 people, they go for shopping complex. and then they invited to attend a briefing on the new product. Okay, something like that. Okay. Okay, then maybe after the briefing, they give some small gift, yeah, or small sample, yeah, to the participants. Okay. Okay. So now, after the briefing, they also been asked, yeah, to answer a few questions. Either they going to would purchase or not the product. Okay. And then also got three independent variable. Yeah, durability. Okay, from 0 until 10. You see the bottom line. Okay, the bottom point. 0 is very poor. 10 excellent. Okay. Okay, means what? Means they give some rating, yeah, based on the product. Okay. Okay. Well, they may actually also do some testing or whatever during the section. Okay. So may test maybe new handphone or whatever. Okay. Okay. Therefore, X1, here got 5 points. Five participant answer, and then the rating is 7.4. It's a mean. Yeah, it's a mean. They take 8 plus 6 plus 10. Yeah, and then everything, and then divide by 5. They get 7.4. Okay. Okay, X2 based on the performance, maybe performance of the handphone. You're good or not good, fast or not fast. Okay, the graphic and so on and so forth. Okay, so X3 is a style, yeah, of the design and so on and so forth. Okay, so therefore here got three independent variable or matrix. Okay, or metric, and then dependent is the non-metric. Okay, any question on the case before we see more detail? I mean, at least understand first the story. Yeah, any question you want to ask? Yeah.
So can I say that the X1 variable durability will have more power to determine whether the customer will purchase or not purchase?
Yeah, very good, very good. This is a conclusion that I'm going to say. Okay, good, very good, correct. So yeah, very good. So meaning that the discriminant power is highest. Yeah, for the what? Where's my pen? Okay. Yeah. So the discriminatory power is the highest, yeah, for the X1 because the difference is quite a lot here. So 7.4, 3.2. Difference is 4.2. Okay. So 7.4 minus 3.2, you get 4.2. Okay. So 6.8 minus 4.4, you get 2.4. Meaning that the customers, these 10 people's mindset, for them, the performance actually different not too much. I know it's still different, but different not much. The style different also is a list, only 0.2. But the durability different a lot. Means maybe this perception affecting their purchase intention, maybe. Of course, there's quite high chance that this will affect their purchase intention. Okay, this is how this method, this what they call, how this MDA work. Okay. Okay. They use this the matrix independent to determine the non-matrix dependent. Okay. Yeah. Okay. So done lah. If no question. So of course this is a basic idea. Okay. DV is a two category. Can use the logistic. Okay, good question. Yeah. Okay. So for this one, can. This one can. But you must put here 1, 0. Would purchase 1, would not purchase 0, 1, 0. Then you can do the logistic regression. Yeah, can. Okay. Okay. Yeah. Okay. In general, this suggestion. Therefore, these two methods, in certain sense, is quite similar. Sometimes quite similar, sometimes not. Okay. Of course, we are going to cover also these two. Okay. So in general, people prefer to use the logistic more because logistic regression, we can get the equation. Yeah, and then also do find the probability. Yeah, and so on and so forth. Yeah. Okay. Okay. So we see next. Yeah. Okay. This one diagram not too good. I do a new one. Okay. can draw a new one here. Yeah. Okay, but you ignore this one. Yeah. A prime will be something like this, but still not too good lah. Okay, it's okay. Draw a new one. Yeah. My drawing not too good, but it's try. Yeah, try. Okay, something like this. Okay, something like this. Okay, A and B. Okay, A and B, A and B, X and also the Y. Okay, we can do Z. Yeah. Okay, so this is Z. Okay, so like this. Okay. Okay, so we have this. Okay, so this is A prime, this is Z. Okay, so I use different color to represent the B prime. Yeah, okay. So the B prime will be something, yeah. Okay. 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 The B prime will be something like that. Okay, yeah. Okay. So now we see A and B, yeah, like this, yeah. So there's some area, means now we want to do the grouping. We still can use this example, yeah. Would purchase and would not purchase. Okay. So this one, purchase. Okay, would purchase. Okay. Okay. Would not. Okay. Yeah. Okay. So sometimes you may make a mistake. Maybe they would not purchase, but you put it into the wrong category. They would not purchase, but we put it under the would purchase. This one may happen. Okay. So therefore, they are not totally like this. Can you see? Okay. Because if totally like this, they are too independent. Means we can get the answer 100%, 100% accuracy. But sometimes not like that. Okay. So. Okay, so how we do? We actually use the original data from A and B. We get the Z. Okay, A and B of course representing the X and Y, but we get the Z value. We get the Z value. Okay, Z value from the X. Okay, from all the X we get the Z. That's why X must be metric. X representing the independent must be metric. For metric, we can compute the Z. Remember, Z is equals to X bar minus mu over sigma for X bar. Okay, yeah. Why Z? Because A and B, because X can be here if only one easy, but can be more sometimes. Let's say here got three dependent, but here still easy. Sometimes different unit. Example, sometimes maybe working experience how many years? Your previous pay how much? In ringgit. Can I say the 4 different unit? So it change to Z. Okay. Yeah. Okay. So you convert to the Z value. Okay. Then we compare. Okay. So therefore, that's why we have this here Z. Yeah. So this Z is the discriminant function. Okay. Actually here should be Y. It should be Y. Y is better. Okay. Yeah. So, okay. Okay. So after this, we can convert. Okay, we converted the value to the Z. Therefore, it's a normal. Let's say they show us normal curve. From A become A prime, B become B prime. Okay. So after that, we see. Let's say the person is would not purchase, and then can be mesh. Therefore, it's fall into this category. But sometimes the person is here. the rating, the points that they get here can be here. Means they would not purchase, but they fall into this category. But the person is here. Let's say Mr. Z, okay, Mr. H. Okay, therefore here. Therefore, it's wrongly predicted. Predicted wrongly. Okay, so therefore, not 100% accurate. This may happen. But sometimes a participant, maybe they would purchase, but we may put it into the wrong category. Therefore, it's here. Can you see? Means the person it belongs to the purple color, but they put it here. Okay, therefore it's wrongly predicted. Also, wrong case. Yeah, therefore not 100%. Okay. Roughly, that's the idea. You will see some calculation later. Okay, any question so far? I mean for this diagram, yeah. Okay, where maybe in the chat box, yeah. Okay, if no, now we see next, yeah. So don't worry, I know the time, so we take a break before 5. Okay? So we continue with the discussion. Okay. This is the decision process. Okay, I think it's quite standard, but we will see one by one. Okay, so the objective, the design, the assumption, and then the estimation. Yeah, we do the testing using SPSS. Yeah, and then do assessing the overall fit. Is quite similar if the F or R squared. Okay, the overall fit. Okay, and then interpret the result. Okay, we see now. Yeah. Okay, the stage 1 we determine. Yeah. Yeah, it's okay. We can discuss a bit more. Yeah, enough time to discuss at least stage 1. Yeah. Okay, stage 2 after the break. Okay. Okay. So determine if statistically significant difference here exists between the 2 or more group priori defined groups. Okay. So example just now would purchase and it would not purchase. Okay. Okay. Means the data is available. Therefore, it's supervised machine learning. Okay. Yeah. This is one of the example. Okay. Machine learning, you will, supervised machine learning, you will learn a bit more, much more actually. This is one of the example. Okay. So at least you got some idea on what you are going to do and how to link the with some programming module. Okay. Okay. Identify the relative importance here of each of the independent variables here in the predicting the group membership. Okay. Group membership means refer to the category would purchase or would not purchase. Okay. And then we see the relative important. It means the discriminatory power higher or lower. Okay. So example, the X1 is the highest because 4.2. Okay. So difference between these two groups is quite high, 4.2. So therefore, the least is the X3, only 0.2. Okay. So means from, of course, it's a very simple example. You will see some output. This one, some measure for us to see which one has the highest discriminatory power, which one is the least. Okay. Okay. So you always understand the concept from the basic idea. Okay, the output will be a bit more complicated. Okay, a bit more. Okay. So, okay. So now establish the number and composition of the dimensions of the discrimination between the groups. Okay. So between the group, we see what are the difference. Okay. The group form from the set of the independent variables. Okay. That is, when there are more than 2 groups, you should examine and name the each significant discriminant function. You have 2 or 3 functions. Okay. Okay. So here also involve rotation. Yeah. Here also involves rotation, but later we see. Okay. Okay. So means we will get few. Okay. We will get few function. yeah, the discriminant function for us, yeah, to determine which individual belong to each group. You get function, okay? Okay. So example here. Okay. Here two groups, therefore it's simple. Example. Let's say based on this score, yeah, the one who score more than 2, they will fall to the wood purchase category. Yeah, less than 2 will be less than or equal to 2 will be fall into this category. Here is a number, but sometimes maybe a function. If 3 groups and above, you will see later. Okay, and which function is the best actually can be we can use rotation method, yeah, for us to adjust the function. Okay. Remember rotation we discussed a bit in the factor analysis. Okay. Okay. Yeah. So this objective that we are going to do means we have to get the discriminant function, yeah, for us to determine the individual belongs to each group or each the membership, okay, the membership, okay. And then also classification purpose, yeah, okay. Develop procedure for classifying object. Of course, linked to the number 3 also, because we use the discriminant function to help us to see the individual should go to each group. Okay, yeah. So the procedure for classifying the object or individual into the group. Okay. So and then examine the predictive accuracy, hit ratio. Okay, higher is better. Okay. So here 25 or more, yeah, is better. Okay. So minimum 25%. But actually try to get a bit more. Higher is better. Okay. Okay. So this for this section. Okay, any question so far? Yeah. Okay. If not, so see you at I think 3:25, yeah. Okay, 3:25. Okay, 3:25. Yeah. So okay, so see you in the shop at 3:25. Yeah. Okay, thank you. Yeah.
Sir, I think it's 5:25.
Okay. Oh.
5:20.
Yeah. I'm sorry. So 5:25. Yeah, you are right. My mistake. Okay, 5:25. Yeah, this one I need a break. Otherwise, cannot teach. Okay, so 5:25. Yeah, thank you very much. Thank you. Yeah. Okay. Okay, so 5:25. Yeah, thank you. See you. Yeah.